Good morning, it's TUBALCAIN and welcome back to the shop. It's a new day and this is part 2 of this little adventure on making the compound for the 6-inch ATLAS-Craftsman lathe. So the next thing I'm going to do, and I've got this roughed out and that's shown in the first part, is to make the dovetail. Now a dovetail, in this case, I think the standard is 60 degrees, so I'll be using a 60-degree cutter. And I've got several of those. This one's a little too wide. That could almost make it in one pass, but that's not generally the way I cut one. I'm going to start by cutting a rectangular slot and then finishing it off with the dovetail cutter. And that's what the cutter looks like. I use that in one of my other videos. Notice that it's 3/4 diameter, 60 degree. So let me go ahead and lay this out first, but it's good to note here that this dovetail is centered on the block here. This portion of the dovetail is offset to allow for the gib. And I measured this already, and it's 1 inch, more or less. There's a 1-inch gauge block that fits just nice, and I need to measure the depth. So I already got some layout die on there, and I'm ready to make a layout. Since this is 1 3/4 wide, I've set this exactly, by the way, and I've set this for 375 thousandths, and I'll scribe it like that. And like that. And that leaves me 1 inch in the middle, you see. Now let me lay it off on the end here as well. The dovetail is 260 thousandths deep. Now there's some clearance in there too that I'll talk about later, but the mid-to-toyo is set for 260. And actually I'll dial that depth in with bridgeport. And that's just the slot that's laid off right there, not the dovetail itself. I'm not going to lay that off. That to be determined, of course, by the cutter. So let's go over to the milling machine, get this set up, and I'm going to just rough this slot out. I'll show part of that. It's set up in the bridgeport, and I have a roughing cutter in there, 3/4 diameter. And you know, I don't make drawings, but that's how deep that I'm going to go. I make notes to myself. I sometimes write it down right on the milling machine. So I have already found the top, and I zeroed out the knee on the mill. So this cutter really cuts between a super sharp roughing cutter and the lead alloy steel. It's a wicked combination, and I think I'll just take I'll go in 200 thousandths to start with. 1, 2. So this will be my roughing cut. Make sure you wear your safety glasses, boy, those chips are hot. And they're flying everywhere. So I'm going to take the slot down to depth, 260 thousandths. in 2 passes, and then I'm going to take it to width. First milling on one side of the slot to the line, and then taking measurements and milling the other side. And the finish does not matter here the least bit. Well, that's removing a lot of metal fast, isn't it? And now I'm coming back the other way to the full depth, so I'll be 260 thousandths deep. I don't know what that is in millimeters for most of the world. I'm now milling this side of the slot, taking off about 100 thousandths, which is almost to the layout line. And now I'm milling the far side of the slot down to dimension. This should be my last pass, and I'll measure. And you say, well, you're using a roughing cutter, isn't it? The finish bed, it isn't good, but so what? Because that's all going to be milled into the dovetail yet, so that material will be gone eventually. Also, you say, why am I not using a 1-inch end mill and I could do it all in one pass? And yes, that's possible. Remember, there's 100 different ways of performing every operation. Make sure you lock your table in the direction that you're not moving. And I am fine milling at the moment. The slot is two-dimension, 1 inch wide, and here's the gauge block. You don't have to use a gauge block. I've been using a caliper too, but I don't know, I like these gauge blocks since I have some extra ones in the common sizes, so that's fitting nicely. Now I'm ready to set up with the dovetail cutter. Now you could do everything with the dovetail cutter, I suppose, but I think at the factory they probably also rough it out with a end mill or slotting cutter or whatever, and then they go in with this. These are relatively delicate and quite expensive, and they would break off right here in the neck. So let me get that set up and I'll be right back with you. And do not take the work out of the mill until the entire operation is done. You'll never get it back in the same. Time out from cutting to talk a little bit about dovetails again and how I'm going to measure this. You need to cut yourself 2 rods, and in this case they're just 1/4 inch rods, but it could be a different diameter too, smaller or larger. Lay them into the dovetail like this, pressing them. I'm pinching them outward, and then we measure in here with the caliper or an inside mic, and I'm getting 615 thousandths. So that's how I'm going to measure this. What I will do is cut one dovetail on one side first, then I will cut it partially into the other side, and then I will start measuring it until I get to that dimension. Then I'm going to fit it with this, make sure that it works. So that's how you do that, and I'm going to write that dimension down on paper, 615, so I don't remember it. Don't forget it, I should say. Back to the mill. I just got a nasty comment from somebody saying, how dare you actually mention brand names from people who have given you things, but that nice roughing cutter came from, I don't care what he says, from the Niagara cutter, and he also said, I immediately give you a thumbs down. So he was quite spiteful about it as well. But the cutter 3/8 diameter shank is in the collet, and I've got that set for about 1100 RPM. By the way, I could have run that roughing cutter much faster than what I did, but I wasn't in the mood for changing the speed. So I'm going to take a trial cut in there. I'm going to take a lot of light cuts. Again, I don't want to break the cutter because I would break my heart and I would quit. There's the dimension. Now I did bring the cutter down until it just kissed the work vertically. And now with a little oil on there, I'm taking my initial pass. The farther you get into your dovetail, the more you're cutting off. I don't know if you understand what I mean there. So there's, in other words, there's more load on the cutter. So I'm taking lighter and lighter cuts. And I'm almost to a sharp point up there. At the top, that acute angle. And when I do get to almost a knife edge there, I'm going to quit and start on the other side. Okay, I finished this side, and I have noted my DRO dimension is 90 thousandths. So if I have to come back and take a little more off of this side, I know where my location will be. But I'm going to start on the far side right now. Unlocking my table. Make darn sure you lock that table, and turn the machine off when you're taking dimensions, measuring, or adjusting anything. And here's how I'll start this side. Always taking trial cuts. That feels pretty good. Now I'll lock that cross feed there, the Y-axis. This is conventional milling in this direction. When I go the other way, it's climb milling. This is what it looks so far, and I think I'll take a measurement before I go too far or go any farther. You can see that it has not come to a sharp angle there yet, but I cleaned it up. You don't want any chips in there when you take this measurement, and then lay the two rods in as such, like you just saw me a few minutes ago. And then I'm gonna do this. When I get down to my much closer to my dimension, I intend to use that inside mic rather than this. But I'm at 590, so I got about 25 thousandths to go. So I am getting close, and as I get close, my heart starts thumping. You know, if I screw this up, I'll wish that I was a golfer. And this, I believe, is my last pass, so I'm going to stop, clean up, and measure it and see what I got. You know, the finish is quite good, but then again, it's still a very sharp end mill. This is only the second dovetail that's ever cut. And you know, I haven't cut a dovetail in a long time, so I had to bone up on this a little bit. And you know what I did? I went back to my other video and reviewed that. It was pretty good, and a lot of people have watched that. So now this is cleaned. There's my rods. I'm switching to the, what is this, a Mitutoyo? Yeah, Mitutoyo. The only thing with a inside mic and let's see what it was. Yeah, inside mic and a depth mic. You got to read them backwards. They're subject to error, but here I'm at about, I don't know if you can see that, 613 thousandths. Now that may be close enough, because remember, I've got a gib. that is going to take up the final dimension here. So let me go over and get the other piece with the gib and see how that fits in there, and then maybe I won't take any more off, but if not, I need to just take off, if it doesn't fit properly, 2 or 3 thousandths, and I'll be done. Again, don't take this out till you're done. You would never get it back. Alright, there's the gib fitted into place on this portion here, and let's see how it goes in. It's only going to go up to that brass nut anyway, but there it goes, it fits. That's how much slop is in there, and we want some slop, so I'm not going to take any more off, that's just right. And once my gib screw adjustment holes are drilled and tapped, you know, that's going to fit just fine. So I'm happy with that. Matter of fact, I'm ecstatic with that I didn't take off too much. Work slowly up to your final dimension. One last simple operation to tell you before, or show you before I take this out of the vise, but notice here, this is the old one now. Into the dovetail here, we got a different depth here than we do here. So that's clearance between my pencil point there and there, about 10 thousandths, and you can see it's just been rough milled, so the finish doesn't matter. But that's what I'm going to do right now. So I'm going to run a 1-inch end mill right down the center, 8 or 10 thousandths deep, to give myself that clearance. So in other words, the dovetail does not come in contact in this portion right here, only in here. So there, it's all set up with the 1-inch cutter. And by the way, as I was changing the cutter, I used my nut buddy here. You know, I have a video on making that, and that's been my most popular video with over 2 million views, and I don't understand it, why there are so many views. Maybe you can explain it. That squirt bottle. So I'll run that right across. Boy, that's a dull end mill. Wow, that was the dullest end mill in the West. So I put a brand new one in there, but it's a 7/8. Believe it or not, I didn't have any more 1-inchers, and that was dull. I threw it away. I suppose I didn't throw it away because it's sharp on the periphery, but dull as can be on the corner. But this will do just nicely. Alright, now it is ready to take out. Finally. That was about 90 minutes work. Well, does it look like a compound yet? Still got the T-slot to go and the holes to drill. But notice at this point, it doesn't go very far because it's hitting the brass nut. And that's the purpose of this groove here that was cast in. And I suppose I should have left it in the milling machine to do that, but I wanted to lay it out. So let me go ahead and lay this out, and then it goes back in the mill, and I'm going to cut a, well, using an end mill that is, let's see what the diameter of this is. That's 1/2 inch, so I'll probably use a 5/8 end mill and make a slot this long, a little deeper than this is high. And alright, let me lay that out. That's going to be simple enough. Boy, this layout sure is not very well defined, but there's the lines, and it will go as far as this mark over to the bridgeport. That's a 5/8 end mill, and I'll take this in several passes. As the great one Jackie Gleason would say, and away we go. Alright, that's done. Ready to take out again and deburr. And it'll go in like that. And now you see we have plenty of clearance for the brass nut on the bottom there. And that slot did not need to be rounded the way it was in the casting. It was simply done that way because the pattern needed relief and all of that. So there we go. We have a full-length slide now on our compound. Remember, this is also called a machine slide sometimes. It's starting to shape up. Looks like a machine slide. There's the gib in place. Now the purpose of the screws here that go into the touch the gib is to not only take up the play, but the screws prevent the gib from sliding out. And the gib screws go into these little holes. So tomorrow, or I should say in the next video, next part, I will drill and tap those holes and make the T-slot. So that concludes this video. I'll see you in the next part.